Bandwidth for Changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at Changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. Do not underestimate the power of the independent open cloud for developers. Yes, I'm talking about Linode. Linode is our cloud of choice, and it's the home of changelog.com. What we love most about Linode is their independence and their commitment to open cloud. Open cloud means being unencumbered by outside investment and maximizing value for the community, not shareholders. And that's exactly what Linode represents. No vendor lock-in, open at every layer. If you want to learn more, head to linode.com/open. Again, linode.com/open. What's up? Welcome back, everyone. You are listening to the Changelog, a podcast featuring the hackers, the leaders, and the innovators in the world of software development. I'm Adam Stacoviak, editor-in-chief here at Changelog. Today, we're talking with Anders Damsgaard, a researcher at the Department of Geophysics at Stanford University. He's working on cryosphere processes. Our conversation with Anders focused on the intersection of open source and climate science, specifically a set of shell tools created by Anders called ScholarF that allow you to perform most of the tasks required when gathering references you need during the writing phase of an academic paper. We also talk about climate science, physics, and why Anders isn't present on any social networks.
So shout out to Brian Zealot for requesting this episode. Definitely wouldn't have come across Anders or his work had it not been for Brian submitting this show request on changelog.com/request. Thanks, Brian. Hope you enjoy this conversation. We have Anders here, a researcher who's working on cryosphere processes such as glacier sliding, sediment mechanics, and sea ice deformation, many of which words I don't even understand the words, let alone the research. So Anders, thanks for joining us.
Thank you very much for having me, Jared and Adam.
So this conversation will focus around your ScholarF tools, which seems like very much you scratching your researcher itch and dealing with pesky internet websites and difficulty of gathering academic papers. Let's start off with your academics in general. Tell us about what you do, what cryosphere processes are. Help me out here.
Yeah, fair enough. So I like to do research in kind of the Arctic setting. So I'm very interested in understanding how ice sheets and glaciers respond to climate change and how rising temperatures result in changing sea level. And in order to understand that kind of change, we really need some good tools at our disposal. And some of the best tools that we have are numerical models for glacier and ice sheet flow. So these are computer models on a quite big scale, and different things go into the models. For instance, the temperature budget, precipitation patterns, and ocean change. And then you get the behavior of the glacier or ice sheet out as an end result. And that can inform you a little bit about how different environmental factors and climatic change manifests itself in glacier and ice sheet sea level rise.
What's interesting about this field, which I'm nowhere near you, and I'm just a novice, just somebody who is curious, I would just say, is that you could sort of go back in time, right? Like ice is essentially, some level of a time machine when it comes to research. Is that what got you into it? What sort of piqued your interest to get into this field?
Yeah, it's definitely, it's actually a climate record also, because you have snowfall, of course, being precipitated on the surface of the ice, and then you have layers upon layers being compacted. So if you try to drill through these ice sheets, it's actually going back in time. And just like tree rings, you can count out as individual years of precipitation. So you can go back thousands of years and understand what happens in terms of precipitation change and climate change, also going back in time. So that's the direct measure on the ice sheets themselves within the ice. But you can also look at previous extent of ice sheets and see how they grew from the northern latitudes and spread on Northern America and the European lowland. And you can see how they just drastically reshaped the Earth's surface during previous glaciations. So we know from the past that these ice sheets can really cause massive change on a global scale. And we're trying to wrap our heads around exactly how that happens, physically speaking.
What does the actual data collection look like? Now you go out there with a measuring stick, or what kind of tools are used?
Some people do that. Some people simply go out into the field and hike with a good backpack and look at the different deposits left behind by the glaciers. But other people also look at remote sensing data sets, so you can discern some of these features from satellite data, for instance, visible imagery. And other people yet look at geophysical measurements. So that would, for instance, be radar measurements taken by airplanes or satellites that fly over the ice sheets. And you can learn a lot about the exterior and the interior of the ice sheets in that way.
It's probably good to have a lot of data points to collect from, because not one piece of data will give you enough information. You can begin to assume and obviously track, if you got an aerial view that's giving you, say, coloration, or radar, as you mentioned, that gives you one data point. But having, physical specimens, or whether it's, data gathered through metrics or sensors, et cetera, it's going to give you a full spectrum view of what's really happening there. Let me ask you guys both a kind of a funny / somewhat off-topic question. You might laugh, so don't laugh too hard. What would you do, or how would you feel if a library burned down? Or a very important library.
Like the Alexandrian Library, for example?
Pick your library, whichever one's your favorite. Would you be upset?
Well, yeah, of course.
So it occurred to me just in this last moment that, that if these glaciers have this kind of data in them and they are melting, basically not being there anymore, unmeasurable, unresearchable, right? That should be alarming, right? Because these are basically records of our Earth's history, to some degree showing our past and potentially our future based upon data. And so that should be alarming.
It definitely is. Specifically in that regard, mountain glaciers in the Alps or other places, they are the ones that would be most affected in that regard, because they are isolated records in remote locations. It takes a lot to melt away an entire ice sheet, but the smaller glaciers themselves are definitely susceptible to that kind of risk.
Curious what your specific work is with regard to this topic. No doubt, as Adam said, like different data points, different people doing different kinds of research. I'm not sure if you're going out into the glaciers yourself, or you like to sit back in your computer like I would and let the data come to you. But like, what specifically are you personally researching, and what are the results of that kind of research?
So I work on improving the physical mechanisms and physical parameterizations in these ice sheet models. So I'm sitting in front of the computer trying to understand and model the system to a better degree than we can do today. So specifically what I'm working on at the moment is the fact that the glaciers actually not really are governed by how the ice itself flows. So you probably both know that glaciers and ice sheets move from high altitudes to lower altitudes because ice is a viscous fluid. But it's actually not to a primary extent the ice flow itself that really controls how the ice sheet moves and why it moves in the patterns that we see. But instead, it's actually sediments like sand and clays and gravel and stones at the base that are very weak because we have a lot of meltwater down there. So these sediments are actually breaking. And what we see on the surface is actually an expression at the base of the ice sheet of where these sediments are failing and where they are weak and where they are actually contributing to lubricating the glacier flow. So these physics are actually not very well understood and more or less not included in the models that we today use to quantify the sea level rise in future climate scenarios. So the estimates that in the year 2100 say that we will have maybe half a meter of sea level rise, maybe 1 meter of sea level rise. They are based on more primitive models. And it's really hard to exactly quantify these maybe lesser, maybe more important mechanisms, such as the one that I'm working on. So we really have to be smart about our computing, and we have to be very efficient also, because the computational costs are just very, very large. So I've worked a lot with GPU computing, and it's really painful, I have to admit. But there is also a lot to be gained when you have something that's working and working efficiently.
Well, the good news is that it's 2020 and not 2012. I don't know if you saw that movie 2012. I know I laugh when I say that it's not very funny if it actually happened, but that movie really was kind of interesting because you had this scientist and, you know, this data and this prediction, and they thought he was crazy. I'm not going to spoil the plot of the movie, but, you know, bad stuff happens, basically. We don't want that to happen. So we want smart people like you in the cockpit of the software and the metrics and improving these. You said they're physical mechanisms. Is that what you said? The physical hardware?
Yeah, actually the physical processes. So one other physical process that we need to understand better is, for instance, how the ocean melts the glacier. So it's not a simple matter of the physics that happen when you put an ice cube into a warm cup. It's not really the same because you also have turbulent mixing of the warm and cold water masses in the ocean, and you have a lot of weird dynamics going on. And you can't obviously model every water molecule. You need to make generalizations. And that's where a good understanding comes in. So we can make the right simplifications, but still grasp the important mechanisms.
It kind of reminds me a little bit of quantum physics too, where you, again, I'm out of my pay grade here when I talk about this. So this is just from a curious standpoint. But basically, if a car is moving, I can predict that the car will move from this point to that point if I can kind of tell that it's moving. But at a quantum physics level, like you're predicting a massive amount of possibility, so to speak, because of the way particles move at the very, very small level. This seems very similar, where your research is sort of keying into the particular particles to make large-scale assumptions. And in some degrees, you're saying that we're making these assumptions on sort of generalized data rather than the specific particles and how they react to, you know, small-level physics.
Yeah, that's exactly right. You have to make the right simplification so you really can do something with your insight and actually apply it to bigger purposes.
Do you also have to focus in on specific glaciers in order to do real world results? Because it seems like, in my layman's understanding, I would think that different glaciers in different geographies under different circumstances are going to also react differently. And so that's probably a challenge as well.
Absolutely. And we already see that happening today. So, for instance, in the Antarctic continent, there is one area which is immensely affected by current climate change, while other glaciers actually are growing. So it's a very regional, there is a lot of regional variability.
Yeah.
And just because the setting is different, that actually means a lot to the outcome.
Does that mean you need to produce different models for different geographies, or how do you attack that?
Yeah, you can do test cases for smaller subsets of an ice sheet, or you can try to model the entire thing, maybe at a reduced resolution or something like that. But there are usually trade-offs with either approach. It's kind of the same as if you're trying to model the ocean. You can try to model everything with, you know, really big cell sizes and coarse resolution, or you can try to model a smaller regional ocean basin with much higher resolution. But with a regional model, you have problems at the boundaries because the ocean also needs to flow across a smaller surface. So you need to be smart about what you do.
What I find maybe, I don't know if ironic's the right word, maybe unfortunate, is here we have this need for advanced technical research in order to improve our ability to make these models, to get accurate predictions and results. And we have a field of academics who are bumping up, in your case, against these technical hurdles of what is really kind of a, ancient's not the right word, but like old school, non-technical field of sharing and publishing and all of the things that you think these people should be bleeding edge because they're on the bleeding edge of their research. Well, it turns out, you know, the scientists aren't software people, or they don't have, I mean, not in every case. And there's just like tons of academia, may I say bureaucracy in certain cases. Like there's lots of reasons. Same thing with government publishing of open data that belongs to the citizens, and it's in formats that are like inscrutable. That seems like a terribly unfortunate circumstance where it's like you're just wanting to do your research, right? But now you're writing your own tooling in order to collect the information you need in certain cases. Is that just like the state of the world? What's your thoughts on that?
Well, yeah. So I specifically had the problem that it was hard to it took a lot of time to get all the publications gathered that I would need to have access to during my research. So often when you are stepping into new research areas, you need to spend a lot of time to sit down and really check the literature. Yeah, so I would say pretty much anybody who has gone online and tried to look for papers and so on, they've probably felt frustrated at some point because the web pages of many of these publishers are just horrible. And so they are extremely bloated and slow, and you have to often struggle to find PDF download links because PDFs are still, a good way to just having precise copies of papers on your own machine. And every publisher is different in exactly how they set up their web page and so on. So I found that to be quite a struggle. So I chose to spend a little bit of time to kind of sharpen my tool set and build something that could help me get around all of these issues and streamline the workflow. And I guess many of your listeners are probably the same way. We probably all have a set of dot files, which we just very much value and continuously tweak in order to just get rid of little hurdles that might occur every day in our workflow.
So I'm curious if you are unique amongst your peers in your research, or if you are commonplace in terms of somebody who's doing climate science, right? Glaciology,
yep.
And yet spends time writing scripts, software, programming, basically, in order to help them along in their way. Like, do a lot of climate scientists have your skill set, or are you unique? How'd you get these programming skills?
I'd say a lot of climate scientists are actually pretty good programmers. So when I was at NOAA in the US, I was at this climate modeling facility, and people have been writing Fortran programming there since the 60s. And they know everything about making really efficient code. So a lot of people in that sub-niche are actually pretty good programmers and do everything they can on the command line. But I did my undergrad in a geoscience department, and there it's the stereotypical image you have of bearded professors in in old-fashioned shirts, and they have no idea about doing really efficient use with a computer. So there are a lot of different kind of groups out there that just have a very different workflow and a very different skill set.
Mm-hmm. Do you know if there's any initiatives out there to pair these people with software developers? I know we see huge strides made if you pair a developer skill set with a designer skill set, or a product skill set with a developer skill set. It seems like a scientist who doesn't have the software chops that some of the climate scientists or more technical modeling scientists have, pairing those people with a skill set like a software developer could see huge gains for both participants. Is that a thing?
Yeah, it actually is in bigger projects, and I completely agree. It's very good to combine different skill sets. So for some of the bigger modeling projects out there, they actually hire dedicated scientific programmers to do things like automated testing and proper documentation in the code, and just things like that, which make life easier and which are commonplace in modern software development. So actually something like version control is pretty recent in the modeling community, I'd say. So of course there are so many benefits to having a proper development pipelines and so on. That's just a complete necessity in modern development. So a lot of good things coming out of combining people with different skills.
How often do you think about internal tooling? I'm talking about the back office apps, the tool the customer service team uses to access your databases, the S3 uploader you built last year for the marketing team, that quick Firebase admin panel that lets you monitor key KPIs, and maybe even the tool that your data science team had together so they could provide custom ad spend insights. Literally every line of business relies upon internal tooling, but if I'm being honest, I don't know many engineers out there who enjoy building internal tools, let alone getting them excited about maintaining or even supporting them. And this is where Retool comes in. Companies like DoorDash, Brex, Plaid, and even Amazon They use Retool to build internal tooling super fast. The idea is that almost all internal tools look the same. They're made of tables, drop-downs, buttons, text inputs, and Retool gives you a point, click, drag and drop interface that makes it super simple to build these types of interfaces in hours, not days. Retool connects to any database or API, for example, to pull data from Postgres. Just write a SQL query and drag and drop a table onto the canvas. And if you want to search across those fields, add a search input bar and update your query, save it, share it. It's too easy. Retool is built by engineers, explicitly for engineers. And for those concerned about data security, Retool can even be set up on-premise in about 15 minutes using Docker, Kubernetes, or Heroku. Learn more and try it free at retool.com/changelog. Again, retool.com/changelog.
So you were bumping into this problem with your research of going out and getting the publications, PDFs in most cases, probably almost all cases. And you wrote in your post about the announcement for the ScholarRef tools that the common tasks you're doing included downloading PDFs and publications, getting references into your bibliography. And you said, however, I'm not a fan of navigating the slow, bloated, tracker-filled, and distracting web pages of academic journals and publication aggregators. And so you came up with this solution. Why don't you tell us about it?
Yeah, so I'd been working on something similar for a little while, and I just decided to properly wrap this up so it could be more useful for me and maybe others as well. And that's what kind of gave birth to the ScholarRef toolset. So it consists of a few tools which can be chained together. So they're written in an old school way. So they're based on the Unix philosophy, so everything should be text-based, and each tool should do one thing and do it well. So the idea is that there are different tasks that are common in this kind of work. So one task is, as you mentioned, Jared, you need to get a reference for a publication. So say you read a nice paper and you want to cite it in a paper that you're writing. So most journals use something called LaTeX, and you would need to get something called a BibTeX reference. So the traditional way is to go to the journal webpage, download text reference in this BibTeX format, which is kind of like JSON, but not exactly. And you would then put it into your own bibliography, which is just a massive text file, paste it in there, and then cite it from your LaTeX document. And the problems with that kind of workflow are actually many. So as you mentioned, I'm not a fan of the journal web pages, as I wrote in the blog post, but also there are more practical issues in terms of the formatting of these references. So even though they share this common BibTeX format, they're actually very different in content. So for instance, the author first names might be written out or they might be abbreviated. And often journals that you want to submit your own paper to will only accept one type of author styling. And the same goes for the journal name. That also needs to have a consistent style. So there are a lot of things that you need to go through once you get a hold of this reference from the journal webpage. So I found out that there's this API publicly available, which I can simply query from a search query. So that actually works really well. And alternatively, I also make it possible to just feed in a PDF document. So one of these tools in the ScholarRef toolset will try to extract the DOI, which is the unique identifier for that publication. So you're not getting any kind of wrong results. So the last thing you want is to get the reference for the wrong publication. And even worse is if you don't manage to actually correct that mistake before submitting. So I've tried to make these tools kind of modular. So in some instances, you might only need the DOI of a publication. In other instances, you might need the full reference in a consistent format. And finally, in some cases, you might actually need the PDF itself. Another benefit from keeping these tools really minimal and simple is that they are quite portable. So they have very minimal dependencies on the host system, which makes them easier to distribute. And secondly, it also makes it possible to work with them from your favorite editing environment. So, for instance, I'm a guy that likes to stick to old school terminal text editors, VI specifically. And there I can simply bind a set of keys and get the reference in a very convenient manner. And you can do that in pretty much any editor that you can think of, because these are just shell scripts. So that just makes them much more portable than many other solutions.
You can tell that you're a VI person because in your editor integration section under Emacs, it says, don't know, figure it out yourself.
Yeah, that sums it up.
That sums it up.
I like that. It's a good response.
Yeah.
Yeah, but most people know how to do that kind of stuff anyway, so it's kind of just teasing a little bit.
Yeah.
Right.
So there's these three main tools, and they're all under the Unix philosophy. They're just shell scripts, and you talk about the importance of POSIX. I thought maybe it'd be a good opportunity for those who aren't aware of that, if maybe you explain why that matters, what POSIX means, and then of course why shell scripts when you could reach for more powerful tools nowadays. Just curious your thoughts on your own tooling.
Sure. So POSIX is a standard which really exists to create a common platform for these computing interfaces. So back in the day, you had quite a few different Unix variants, and many of these would have their own kind of implementations of basic tools, and they started to differ in options. And for instance, the GNU toolset, which is common now in Linux distributions, is really expanded with a lot of command options and so on that are not necessarily the norm on other systems. So if you want to have something which is really portable beyond just a specific environment, you need to adhere to the broadest common standards. And those would be the POSIX standards for scripting and for the different tools in the Unix environment. So that's why I chose to go with those tools. And also something like just POSIX shell is much more rapid than a more complex shell interpreter like Bash or ZSH or something like that. So by keeping it minimal and adhering to these strict standards, you usually also get very good performance besides the portability. So that's a definite advantage.
So I didn't get a chance to look at the source code, and I'm curious, how large, lines of code, like how big are these individual tools? Is it, because at a certain point, POSIX shell is like, it can become unwieldy. It's a sharp tool. You can cut yourself with it. And I know myself, having cut my teeth in Perl and Ruby, I very quickly I'll start with just a shell script, and then anything beyond like 10 lines, and I'll go reach for a scripting language.
Sure.
And so I'm curious how complex these got.
Oh, these are quite simple. Most of the source code is actually like helper things like the help text itself,
right,
and version info and so on. So the scripts are really minimal. But you're absolutely right. If you want to do something complex, you should go for Python. But then again, something like the lag just from starting a Python program is quite significant.
You mean startup lag by the time you type the command in?
Startup lag specifically. And of course, if you want to do anything which has a lot of iterations, which these tools don't. But if you wanted to do that, then Python is not ideal, of course. But you really need to pick the language appropriate for the job. And shell scripting was the appropriate thing for this, I think.
The other decision that you have to make, which you have made, is when to formalize a project and make it a public thing, make it an open source available thing. Many of us have like random scripts laying around our machines. I know I've written plenty of things that'll never see the light of day. And sometimes you write them just enough to like take the pain away, but not enough to like take other people's pain away. And so, then you never get the limelight, you never get to come on the changelog, but you have your own little scripts. And I'm curious, how long, what was the process of writing these? Did you have it formalized for a long time? You just didn't have the help text? And what made you push you over there to say, okay, this is very useful for me. This can help out hundreds, thousands, who knows how many other researchers out there feeling these pains. I'm going to go ahead and put the extra effort in, because even the thing that's like almost ready for the public is not ready for the public. And a lot of the window dressing, so to speak, is the effort, as you probably realized in this project if you haven't had other open source projects. So when did you decide to formalize it and take it public?
Well, to be completely honest, I just put up a new web page and I needed something to put on my blog. But you're absolutely right.
I love that honesty.
It takes a lot of time to kind of wrap things up and present things in a coherent manner and to make just things nice and presentable, and adding niceties such as help text and so on. That takes a lot of time. And you're absolutely right. I really want that. It would be great to see that people openly share kind of little niceties that they've carved out for themselves, because there are so many clever things people invent out there, and it's just a good idea to share that.
The one interesting thing I think here with this conversation and specifically what you've written here is that it's not on GitHub.
Yep.
So I almost thought you'd release this so that you can declare and advocate for self-hosting your own Git, which I'm really curious why you're doing that.
Here, your next blog post.
And I would say even a follow-up to that would be, for those listening to this thinking, I want to get into this, or I want to check it out or reference it to my research friends or whatever it might be, would they be disappointed to see that self-hosted Git and there's no collaboration, or seemingly no collaboration, because it's not on GitHub? And GitHub is generally social, and you're against social networks to some degree.
Before you answer that, Anders, I'll just say, as a casual observer who's interested, probably not going to have to use your software, but was like, oh, this is cool. I admitted freely a few minutes ago, I haven't read the source code, and if it was on GitHub, I would have by now, because it's a click away, whereas this is a Git clone away, just another step. I would have been able to click onto the files and seen your scripts and maybe learned a thing. So that add some salt to the conversation here. This is self-hosted Git. What's the decision there?
Sure. To address your comment about clickability, I actually have a web front end for the Git host that I have. So it's a little C program that writes the repositories out as HTML, and you can also actually go and click and look at the source code and so on.
Touche.
It's actually pretty cool too. It is pretty cool.
I didn't see that. I'm seeing it now.
Nice styling on this as well. I can almost see this as being a kind of a, like if somebody took this and said, let me, do a CSS restyle of GitHub, and like where you can sort of, what is that called? Like CSS styles, or what is that? What's that style sheet replacement?
The old Zen Garden, CSS Zen Garden?
Well, not like that, but where you can actually put it into Chrome or Brave or whatever browser you use, where you can actually restyle a website. So make GitHub look like this.
Oh, yeah.
This
is very hacker. GitHub is not very hacker these days.
Firefox had a whole scripts thing. What was that called? Probably still out there. Our listeners are hating us right now.
Sure.
Anyways, user styles? I don't know.
User styles. There you go. Good job.
Okay, so touche, Anders. You got me on the clickability. I'm just now seeing that.
In terms of collaboration, there is not a lot of the GitHub niceties, such as issue tracker. There is not, open pull requests and things like that. None of that is there. And in the README for the Scholarref tools, I invite people to contribute changes by sending patches over email.
Uh-oh.
So that's the old school way of doing it.
So wait, hang on. Wait.
You and Linus, yeah.
So you wanna modernize the way that research is done, yet you want to rewind time when it comes to source code control and just the way that software has kind of evolved for collaboration.
Well, modernizing does not necessarily have to mean that you put a fancy GUI on top of everything and just put lots of JavaScript and CSS just to completely drench whatever information you're trying to convey. Modernizing.
Is that how you describe GitHub?
Well,
I'm just pulling your chain.
Yeah.
I guess what I mean by that is that it's sort of socially acceptable that GitHub is not so much the way, but it is a way to collaborate, and it's a collaboration tool. And so you're sort of going against the social norm here.
Sure. Well, I definitely am open for collaboration on this project and any of my other software projects, which used to be on GitHub, but I pulled it down because I was not really happy with where GitHub was going as a company. And, thinking about the web as a whole and where the web is going, it doesn't really make sense in kind of when you think about the architecture that everything should become more and more centralized. I think the web should really be a distributed thing, and there is nothing with my source code and so on that stops you from just copying everything and starting on your own on GitHub or wherever.
Right.
Because everything is very liberally licensed, more liberally than the GPL for that matter. So, I think there are lots of reasons to look beyond these mega source code databases, because it doesn't have to be that way. And I don't personally see the massive benefits of that.
Has there been any thought, this is totally a tangent, so forgive me, but has anybody, or have you put any thought into this idea of, the traits and attributes that feature set, I suppose, that GitHub offers in a decentralized way, where you don't have to have a, this kind of repository where it's, controlled by a large corporation in this case, previously ran by, tried and true hackers that sold their company to Microsoft, which isn't a bad thing. It's not, there's nothing against that. It's a choice everybody makes. So there's trade-offs. But the point is that I can recall a day when GitHub was rid I'm sure it is. Geez, I'm saying negative things here. Great. GitHub's great. People behind is great. It's hard work. I'm not trying to, shame anybody here, but, it is now owned by a corporation and not by, 3 hackers that got together for beers anymore. It's grown. It's changed.
Sure.
And so that can't be glossed over. It's not the way I suppose it is these days. How do you get to a point where you can kind of have your cake and eat it too, so to speak, when you want to, have your own self-hosted Git, but provide collaboration opportunities, the way that GitHub has socially normed collaboration when it comes to source code and open source?
Yeah, well, of course, it'll always be a trade-off. So because you kind of leave many of these GitHub niceties behind, you might also put yourself at risk with damaging any collaboration that might otherwise present itself. But then again, if people are interested enough, that you get pull requests which just go beyond basic typos, correcting basic typos and things like that. If people want to contribute, and really make something significant and provide some significant changes to a software project, I think they'll get in touch no matter what the communication platform is, to be honest.
Yeah, so I have a couple of thoughts on this. First of all, we should note that GitLab began because of this. It was self-hosted. It was supposed to be federated with regards to collaboration. There's been Gitorious. There's been other software projects that are basically like, what if we had GitHub's niceties without the GitHub? Of course, GitLab has turned into another large corporation that services the enterprise, and I think their open, social, public side has not taken off like their enterprise side has, or like I should say GitHub's has. Many hackers out there running their own instances of Git for sure, and they just make that trade-off. I do agree to a certain degree, Anders, where what GitHub and the bringing together of all the developers in one place has provided for projects is visibility and casual contribution niceties. But software collaboration was happening before GitHub. It was happening. You just didn't see it because it was emailing patches around, right? It was behind the scenes and it wasn't quite as public. I think to a certain degree, people who are serious and benefiting from the software and already understand Git tooling, they can get around the hurdles. That is, this is not a non-GitHub setup. That being said, you're probably missing out on some people who would contribute but aren't, and may start off as a casual contributor and turn into a more serious one. I was curious, Anders, if your move off of GitHub was around the Microsoft purchase, or if it was before or after that, if that was like a major contributing factor in your move away.
Yeah, after the Microsoft purchase, I started looking around and actually was on GitLab for a little while. But, just realizing that these are corporations, they are acting in their interest of shareholders, which corporations should totally do. That's kind of their thing. But you don't have to constrict yourself to that framework. So, just thinking about the alternatives out there with self-hosting and so on, why not? That was just kind of my reaction to that. And I looked into what it would actually take to set up something like that, and it was extremely easy to get up and running. So I just went with it, and so far so good.
So is the C program front end that you're using, is that open source and available? Did you build that or did you find it?
I didn't. Yeah, so that's open source. It's called Stagit, Stagit, and it's a very minimal program, very nicely written also.
So one thing that's fascinating, of course, we've tracked the acquisition of GitHub by Microsoft since the day it was announced, and we've had many people on the show since then and different reactions. And my personal reaction thus far, it was kind of a wait and see, and now we're a couple of years into it. And I think in terms of the product that is GitHub.com has improved dramatically since then. I feel like the relationship between the corporation and the community has improved in many ways since then. So I've seen mostly positives from that acquisition. That being said, there are casualties along the way. Adam, I interviewed Ned Batchelder for our Maintainer Spotlight series, and Ned told me a story of a guy who was like, I told you about him. He was like this traveling contributor. Remember that? He would pick a project for 3 months or so, and he would contribute to that project, and then like heavily, not casually, like he'd get all into it. He'd make major contributions, and then he'd move on to the next project. It's just the way he did open source, which was very unique. And his name is Loic Dashery, I think is how you say his last name, French fella. And Ned had benefited from his contributions and was just kind of singing his praises. And I said, we should get Loic on the show. And the other day I went looking for Loic, and he's not on GitHub. And I couldn't find him. And I found his website, and he left GitHub. Like similar to Anders, he closed his account, and his was specifically like the day Microsoft acquired GitHub, he was gone. And so I'm curious if he's still doing open source. He's not doing it on GitHub like he was. And so there's definitely been, downsides along the way.
I think similar in nature in the way you might do what Anders does here, which is research glaciers for this deep data. You can, sort of hypothesize where things are going based upon, past, present, and potentially the future. People are doing similar aspects of that towards open source and then also GitHub, because, what suffers from this is, I would say, the improvement to software, and then as a effect of that, the human race, because our lives change and, get better or worse because of new software in our world to do different things, or in this case, do research. You sort of get to this point where, the loss really is at the open source level. GitHub is there trying to do one thing, and this is totally not even a GitHub show, gosh. But anyways, we're sort of in this mix here where you have this sort of love-hate for this corporation that owns it. And I'm kind of with you, Jared. I didn't have the same opinion at first, but when you said, let's wait and see, I said, I agree, let's wait and see. And I think most of the things that have come from it have been fairly positive, but what you see is, and I'd love to talk deeply with Anders and others like Loic to see like what specifically has their open source life been like since leaving GitHub, and is it worth the loss that the software / community / open source would benefit from, to leave, to not participate. Because everyone's there. I mean, there's a lot of people, when I say everyone, it's only in masses, not everyone. Like, yeah, the critical mass is there. So you, Anders, and others have decided to not participate.
Sure. Well, on a personal level, it really kind of is about control. So, for instance, say that you have an Android phone and you upload all of your photos to Google Photos. Once you're in that kind of framework, it's really hard to migrate away from it once you've invested in it. And of course, you can always clone or push your Git repositories elsewhere when you have a local mirror. But modern software development on GitHub is not just the code, it's everything around it that we discussed. It's the issues, it's the pull requests and the wikis and all of that. And to my knowledge, it's a far bigger issue to move that around to a different platform in the case that the GitHub Corporation and Microsoft decides to take the platform elsewhere. So it's about keeping that control. And it doesn't have to be the way where you just give it up for free to this corporation. But actually keeping it to yourself is kind of an advantage in my opinion.
Which is the beauty of Git and distributed version control, is that as long as you don't extend into the full feature set, or you're willing to give up certain aspects of the feature set, like GitHub issues, you are still in control. Like, they are hosting a snapshot, right? Many snapshots of your code over time. But as long as you don't couple yourself to that corporation, you can always go get what's it called? Stagit. You can always go set up your own deal, because we have this. You have everything, and moving away is feasible. Maybe it's going to be more painful the more you buy in, but it's still feasible at any moment. And so, when something bad happens, you are free to leave. Whereas with other things, they have everything, right? They have your data. You don't have your data. They have it. Like, it's on their computers, not yours. At least with Git, it's on both computers.
Right. There's copies. And that's actually the exact beauty of Git, is that there is multiple copies, and someone can recover it should something happen to one of the versions of it elsewhere, or the nodes of it elsewhere, or copies of it elsewhere. I'm curious, Anders, are you this is maybe going one more layer deeper. Are you against having your code on GitHub? So did you wipe all of your code away? Did you just sort of like just vacate and stop being there? Or did you delete?
I deleted for the purpose of not confusing people that were interested in specific projects. So I specifically shut down everything to the bare minimum, pretty much. So for me, it's not just about the code itself, which of course you can have distributed among multiple platforms at the same time, but it's also about providing, access patterns to the platform. So, the saying that if you're not paying for it, you're not the customer, but you're the product being sold. And GitHub is not providing this platform to their users out of their heart's goodness. There has to be some kind of money involved, of course, because it's a corporation. So the wheels have to turn, and they're making money somehow, just like Facebook and the others.
Well, it's worth differentiating GitHub from Google with regards to their business model. So GitHub business model is more straightforward. Like it's a freemium model versus an advertising model. GitHub is making money off of their more power users and organizations, paying them monthly a certain amount of dollars in order to have more features, versus Google, where everything is free and they're making it via advertising. So it is different in that regard, insofar as you are the customer if you are a customer.
Right.
But it's a freemium model, so they give it away to people who they want to eventually become the power users. So it's a little bit less behind the scenes in that regard, because their business model is more money for features.
Sure, absolutely. I agree with that.
Have you heard of our newest show called Brain Science? Yes, Brain Science. It's a different kind of show, I know, and it's probably one of the ones that reaches the furthest out from our typical listener audience, but this podcast is what we call for the curious. And what's cool about this show is we're exploring the inner workings of the human brain to understand things like behavior change, habit formation, mental health, and pretty much what it means to be human. If you've ever thought about why you do what you do, or why others do what they do, then this show is for you. Head to changelog.com/brainscience to listen, subscribe, and learn more about this awesome show. Here's a preview of a recent episode called One Small Act of Kindness, talking about empathy and mirror neurons. So it sounds like pliability and flexibility is a pretty crucial role too in relationships, because if you're not flexible, bendable, pliable, whatever, however you want to phrase that, if you're rigid, right, it's going to be difficult for you to flex,
right,
to enable change, or to, what you've said before, recalculate.
Yeah.
Accept new data, analyze that data, make a new plan, and iterate towards a new action.
Yeah. And so one of the other things involved with this flexibility would be what researchers have discovered as mirror neurons. And so mirror neurons are these neurons within the brain that help us sort of get access to another person's emotional experience. And so there's an action component in it that it was first discovered actually with monkeys, and this sort of mimicry that occurred by watching somebody else do an action. Well, in the same way, I can sort of watch somebody else walk through something in terms of an emotional experience. And if I'm holding space for them in my mind, like my body physiologically, these mirror neurons come to play.
All right. To keep listening, head to changelog.com/brainscience/9. That will take you to the episode titled One Small Act of Kindness. Marielle and I dig into this thing called empathy as a construct. We ask questions like, what key brain structures are involved? How can we better understand empathy to be able to better navigate ourselves and our relationships with others, both at home and in the workplace? It's a deep subject, a very fun subject. Again, changelog.com/brainscience/9, or search for Brain Science on your favorite podcast app and subscribe. We'd love to have you as a listener. What are the ideal users for this tool? I mean, if we're looking at who could become a drive-by user, not a contributor, because that's a more difficult path, as we mentioned, but a user seems a little easier. Git clone, that's pretty possible, but who's using this tool, and what's needed in this space?
So I'd say the typical user is probably not afraid of the command line, specifically because these are shell scripts. It kind of takes a little bit of fiddling to make it work with whatever you're editing your manuscripts in. So people would probably be familiar with a little bit of coding, and many people are that today within academics and so on, especially in the technical sciences. So I'd say if you're not afraid of the command line, give it a go and see what happens.
What do you say to the idea of, say, climate science dabblers, those who might be, like, I'm a curious person. We have a show called Brain Science, and I'm brain science curious at least. And I've actually listened to quantum physics books, and I've listened to, and I say listen to because I've listened to books a lot more than I read books, but it's still reading in my opinion. I've listened to, large scale lectures about actually how time works, how we travel through time and the actual physics of time. So I would say I'm maybe in that wheelhouse, although I'm not really digging into climate science. But for those who might be similar to me or somebody who's curious like I am, that might come across not so much this tooling, but the space, the need for more brains in such a important space to say, if the sea levels rise by what you said earlier, which was 0.5 meter in the next 100 years, well, that's a problem.
Yeah, definitely. And as long as people have an interest like yourself in kind of sciences and what's going on there are definitely a lot of contributions that can be made by people like you. So, for instance, a lot of the modeling tools that are out there under open development, I'd say the far majority of them are developed openly. And a simple contribution to some of these models could be to take a look at the source code and just check it out and kind of get a feeling for what's going on. And they often have quite good documentation also that kind of helps developers or people that look into the source code to try to understand how it all works. And maybe you find something that's missing. Maybe you find something that you as a person with your background could contribute to maybe the development or maybe the code itself. Maybe a way of optimizing some kind of algorithm. Maybe a lot about a certain set of test tools. For instance, it's pretty easy to get things up and running on Travis and similar CI platforms. So it doesn't necessarily take a lot of effort to get different models up and running on these testing frameworks. And that allows the developers behind these models to really make much more clever development as they go, because they can see if the intended changes do the correct thing that they wanted to do. And so there are a lot of things that maybe people with purely developer backgrounds can contribute just from their skill sets to these kinds of models and communities. So we're all open arms in that regard. And I think people would be very well welcomed to that community.
That's good to hear, because sometimes when you get into certain fields, I've heard this at least from Muriel, co-host on Brain Science with me, about the brain science field, the neuroscience field, that it can be kind of
cliquey.
I wouldn't say, her words wasn't catty, but just sort of like arrogant, I suppose. And maybe these are just putting words into her mouth. I don't think she said this verbatim, but basically the effect was that, I know a lot.
Unwelcoming.
Yeah, not very welcoming, because there's a lot of specific research and specific opinion formed from research, and a lot of gatekeeping, so to speak, when it comes to entrance and participation. And, even credential checking, like which letters do you have after your name? Okay, you're not welcome, kind of thing, similar. And so that's not the case here, or not so much. Or it is, but it's not so much. I'm only seeing that based on his face. We got video here, so I'm seeing Anders' face as I speak. He's like, well, there kind of is, just with his face. So use your words.
There can definitely be sharp elbows between maybe different models. There are competing models, and people want to do, make the most precise model out there and so on. And there will never be a precise model just from the nature of the problem. But there is a lot of competition and so on. But if your intent is to just provide a positive contribution to a project as an outsider, you would be very well welcomed. I'd say you're not in there to break something. And if you're trying to, you'll probably be told off in a nice way.
Right. Are you trying to be right, or are you trying to solve the world's problems?
Exactly.
Like if you're a scientist trying to be right, well, then your right may not actually be the right.
Yeah, exactly. There's another saying, all models are wrong, but some are useful.
Okay. I like that one. there's another saying, all models are wrong except for mine. Mine's correct.
Good one, Jared.
So maybe as a closing topic, which is there's no clean segue to, but I think will be enjoyable regardless, is that you have published some really awesome photography on your website. You're not going to find it on Flickr. You're not going to find it on Instagram. Well, maybe it's on Instagram. I don't know. You're not on social networks, but you're going to find it on Anders' website, which we, of course, have linked in our show notes. And before we started recording, we were talking about the need for an analog or for something completely different. And while you're not out in the field gathering this glacier data, you're sitting at your computer gathering data, you still get out and you take photos. So tell us about that hobby and how you got to, I mean, in my layman's opinion, you're really good at it. Like your photos are really high quality. Tell us about it.
Thanks. I appreciate that. Yeah. So I think it's very important to have something which is distinctly different from your day job. And most of my hobbies are also computer centric. So I decided that I needed something in my life which is analog and away from the entire thing. So I started getting into photography, buying the latest megapixel camera monster. And then I ended up sitting in front of the computer doing post-processing anyway.
Come on. What's the megapixel monster you're working with? What is that?
It was a Sony A7R. A7R. Oh, it was the original one.
Gotcha. Well, that's an amazing camera.
It is, but I sold it because I ended up just sitting at the computer doing, spots healing in Photoshop anyway. So now I'm using film cameras and I'm developing pictures in the darkroom and in a spare bathroom that we have.
Oh, that's
completely
cool.
Analog in the red lights like a dad from the 70s or something like that.
Yeah.
So it's a lot of fun.
Is it exciting? So the thing about, I mean, I only know that world from the movies. And in the movies, they got the shot, but they're not sure if they got the shot. And it's going to reveal something that's integral to the plot. And they have to wait, like the waiting to see if you really got what you needed. Is there joy in that, or is it just annoying?
Oh, there definitely is a joy to that, as long as you're not a press photographer or something like that, I suppose. But
right.
It's kind of forces you to be very deliberate and also forces you to be very methodological in your image capturing process, because you have to get it right and you're spending money every time you click the shutter because you're running through film. But it's a slow kind of processes which involves your physical presence. You have to make sure that the chemicals are mixed right and stuff like that. You can experiment with a lot of different things in the process. So it's a lot of fun, and it's nice to have a complete break from the usual.
One of your series that I liked a lot was the one on patterns. And I think that's what's interesting in this world is I noticed this when I got a drone and started doing a little bit of aerial photography, is that these every day, like right outside your home, just go outside 100 feet away from your home or 100 meters, whichever system you use, pick a length. And, if you can get 100 feet up or 300 feet up above the ground, you'll see something very different than you will see on the ground. And I love that about the world, how there's just like patterns and unique things, or when you zoom in at a very micro level, how things look differently than, say, just a few feet away. That's so cool. I love this gallery that you got going on here. It's got the different landscapes and stuff like that. It's pretty cool.
Thank you very much. Yeah, it's definitely healthy to look under the surface of just everyday things, or just, very far away from the surface to get a new viewpoint. And it's healthy for the mind, I think. That's also why I chose to go with black and white, because it's just a different way of seeing the world that's not common to a normal vision.
Yeah, absolutely. What advice would you give then to those listening who are like, I don't have an analog? How did you find this analog for yourself, and what has been the benefit to your career? Or just less about career focus and more just your life. How's it changed your life?
Well, I just wanted something which got me out of the house, basically, and it kind of allows me to take something home from when I'm away from my usual environment. So people looking to do some kind of new hobby for themselves, which could be some kind of analog thing, maybe just try to explore what makes you happy and what kind of clears your mind from the usual churn. So just try out a lot of different stuff and see what sticks.
Jared, I want to point the question to you, or I guess somewhat of a statement, I suppose, and you can respond. But what I've appreciated is what I assume is one of your analogs, if not many of them, is your love for riding on a tractor and planting trees and taking care of bees. That's such a cool thing. So what's your analog, Jared?
Well, you just said it. I mean, I have a lot of
Is
things
that
I
it?
do. I do a lot of things in the real world. I play basketball a couple times a week. I coach sports, youth sports. But as far as like, I like to get my hands like in the actual dirt. And I didn't know this about myself until I accidentally bought an acreage a few years back, which is a longer story. Not going to tell here today, but I love planting trees specifically and nurturing them and watching them grow and thinking about. I've probably planted on our land maybe 400, almost 500 trees over the last 4 years, and just thinking about what they're going to be like 10 years from now, 20 years from now, and then even after we're dead and gone, that heritage or that legacy is really cool. And I never would have thought I'd be into that kind of a thing until I got out and started doing it. And I'm like, wow, this is really, really enjoyable.
Yeah.
So that's me.
The dirt. Well, something cool about the dirt is actually it's alive. I don't know if anybody can speak to this, but there's our soil, so to speak, is alive. There's a lot of living organisms in there, microorganisms that are very, very important. And what we do in today's society is basically covered up with cement. It's like, here in Houston, we call it the cement village, or was it cement
concrete jungle?
Sorry. Yeah, concrete jungle, because it's just, we just are fascinated with like just covering up our amazing soil with cement. It's terrible.
Goes back to that Counting Crows song. They paved paradise and put up a parking lot.
Oh, man. There you go.
All right.
Well, that's terrible.
So, Anders, one last question on your analog, because I don't understand this world at all. When you switch to the film then, and you're doing them in the darkroom, how do you then get them back into digital format to put them on a website? Or do they scan, or how does that work?
Yeah, I scan them. So that's kind of the easiest way to do it, to deal with reflections and so on. So scanning is the way to go.
Gotcha. Just wanted to ask.
Yeah.
It's always, they got us locked in, right? These machines.
Yep.
It's
You're
how we're
subject to
communicating
them.
now.
You finally escape, and then you go digitize it and put it back onto the machine.
Well, at least you're minimizing them, right? I mean, you're minimizing the amount of exposure to the digital world, which I think is pretty important. It's an interesting thing to even think about, is like minimizing your exposure to, limited data, right? Because like even here, we have a lot of data informing us about this conversation and these relationships in this conversation. I can see all of you. We're on Zoom and we can see each other's faces, but it's still a limited data set. We're not in the same environment. We don't hear the same cars or things passing by. We don't hear similar things. There's a lot of things we're sharing, but not a full spectrum of data. And I think that's kind of bad. You're misinformed about the life you're living and who you're living it with. There's more data to be had.
So what you really want is smell-o-vision. You want to be able to smell what I'm smelling right now.
You had to go there. We're too far in.
Yeah.
What do you think about that, Andrew? The limiting of, I suppose, digital exposure. Is that a thing you thought about? Or
yeah, definitely.
Yeah.
For instance, I'm trying to minimize my cell phone usage just at the moment, and I think it's just healthy to step away. And we didn't evolve to be constantly stimulated by electronic devices. So our brains and our, just mental presence is really suited to slower encounters and to more in-depth conversation that you might get from flickering through a social feed or something like that. So it's probably worth, just stepping away a little bit and feeling yourself and
right.
to engage in other things as well.
What have you read to inform that opinion of we haven't evolved to be stimulated by digital devices? Is that just an opinion, or is there any book? What I'm really trying to get is there any book you can reference that you read and you're like, man, this blew my mind, and this is not how we should evolve, and you're on a street corner, on a soapbox or something like that, telling the world.
No, I'm too busy with research to really read much extra than that, but just thinking about the timescales. So we are several millions of years old as a species, and the digital revolution is not even a blink of an eye. So there's no way that our physical form really has adapted to any of that. So definitely makes sense to just take it slow sometimes.
Well, clearly we can keep piquing our curiosity and go deeper and deeper, but let's leave it there. Anders, thank you so much for do what you can to limit your exposure to this digital world, but still sharing this unique tool set and your love for photography and your care for, the future of our world, which could be resulted in more water or less. It'd be terrible if there was more, though. We need to keep the ice where it's at.
Thank you very much for having me, Adam.
All right. Thank you for tuning into the Changelog. If you aren't subscribed to our weekly newsletter, you're missing out on what's moving and shaking in software and why it's important. Hate email newsletters? Fun fact, killthenewsletter.com was created by someone just like you who wanted Changelog Weekly so bad, they wrote a program to subscribe on their behalf. And of course, it's 100% free. Fight your FOMO at changelog.com/weekly. When we need music, we summon the Beat Freak, Breakmaster Cylinder. Our sponsors are awesome. Support them. They support us. We've got Fastly on bandwidth, Linode on hosting, and Rollbar on bugs. Thanks again for listening. We'll talk to you next time.
It's my slogan for when I run for office. We need to keep the ice where it's at, okay? And everyone will adopt that.
Exactly.
What's funny is your seemingly antisocial move of not being on GitHub, which you'd think would reduce your visibility, has actually backfired, and now you're getting visibility because of it.
Yeah, it's terrible. It's terrible.
Because like the tools are cool, and it was like when I first went to your website, I thought this guy's interesting. I watched your video of your research. I'm like, all right, interesting guy. And then I went back to Brian's request, and he's like, and he's on self-hosted Git. And I'm like, oh, so there's kind of like two facets. And I was like, okay, that's a good guest right there. And so that aspect of it, which was antisocial, became social.
Cool.
Yeah. So sorry, it backfired.
Yeah, it totally did. And now I'm on a podcast.
Now you're on a podcast.
Exactly.